Today we're going to talk about continuity and look at continuous graphs. So I have a few examples of continuous graphs here and a few of discontinuous graphs. Continuous graphs are graphs where you can trace the graph without lifting your pencil, as you can see here. So these are all examples where you can trace these graphs without lifting your pencil. It's one continuous smooth curve. Same thing here, it's a nice continuous line. And so on and so forth here. Here are some discontinuous graphs. And so in this first example, this is a nice straight line and it keeps going on forever and ever, up and up. But there's a hole in the graph right here. So to go from the left side of the hole to the right side of the hole, you have to pick up your pencil and then continue writing. So this is discontinuous because there's a hole in the graph. Now every x value has a y value, so this closed circle up here means that at 2 the y value is 4, but you still have to pick up your pencil to draw that point, and then you come back down here. This next one is called jump discontinuity, where you're drawing your graph, and then once you get to 3 you jump up to the next part of the graph and you continue on and draw the next part of the graph. So even though every x value has a y value, once you get to 3, looks like the value at 3 is like 0.5 or something like that. Then you jump up to 4, so at like 3.00001, the value is around 4 or something like that. And then here, this is called infinite discontinuity, and we'll talk about all these different types here in this video. But this one, it approaches this vertical line both on the left and on the right. So this graph kind of swoops down and then swoops down again. So we'll talk about why this happens. So the first type we're going to talk about is called jump discontinuity. And what we're going to do here is we're going to make a table for each part of the graph. We're going to make a table for this section and for this section. So this is a function where it's x squared plus 1 for all x values less than 0. And then it's f of x for all x values greater than or equal to 0. So let's make a table. We'll start with red. We'll use red for this top one. So x squared plus 1 for x values less than 0. And give me just a second here. I forgot to plug in my little writer thing. There we go. So we've got x and y. What I'm going to do is just pick some x values to plug into this. So I'll go -2, -1, 0, 1, 2. Oh, but wait, guess what? We don't do 1 and 2 because those are not less than 0. Now you might be thinking, well, we shouldn't do 0 because it's not less than 0, but we do want to do 0. We'll talk about that when we're graphing it. So just pick x values less than 0, -2, -1, and 0. You could do -3, -4, and so on if you want to. So -2 squared is 4. 4 plus 1 is 5. -1 squared is 1. 1 plus 1 is 2. And 0 squared is 0. 0 plus 1 is 1. So let's graph these 3 points. -2, 5 would be up here. -1, 2 is right here. And 0, 1, what we're going to do is put an open circle. And you might be thinking, well, why do we do that? Why don't we just start at -1? Well, because at -0.00001, there is a y value, because that's less than 0. So we're doing all real numbers, not just whole numbers, or integers, I guess, in this case. So we do want to include everything between -1 and 0. So your graph's going to look something like this. It might be a little more smooth than mine, but it looks something like this. So for the second part of our function, we'll do this in green. We'll make a little xy table. And since it is greater than or equal to 0, we'll start at 0, and then 1 and 2, and that should be good enough. When x is 0, that means f of x is also 0. When x is 1, f of x is also 1. That's because it's just x. And when x is 2, f of x is 2. So we've got 0, 0. This would be a closed circle because it's greater than or equal to 0. 1, 1, 2, 2, 3, 3, and so on. Something like this. So this would be jump discontinuity because from the left side we approach this value, and then from the right side we approach this value. There's a vertical jump in between these two parts of our function. So it does pass the vertical line test, so it is a function because there's only one x value, one y value for each x value. But it does have a break in the graph, so that's why it's called jump discontinuity. Okay, let's look at the next type of discontinuity. This is called infinite discontinuity, and this happens when you divide by 0 most of the time. There is going to be an example of when you divide by 0 where this isn't the case. So I have this in my calculator. I think I have it on the other one. So yeah, let's look at the first example here. We'll look at, here we go. We'll look at this other example in just a minute. So let's look at the graph of this 1 over x plus 2. And it looks something like this, where it hugs the x-axis, and then all of a sudden it swoops down at 2, and then it comes from up above, hugging the x equals 2 line, and then it swoops down and goes toward the x-axis again. So, why does it do this? If we look at the table, and there's an error at -2, we'll talk about that in a second. Let's just graph these points, and we'll talk about why is there an error at -2. So it looks like, I should probably look at the points, -5, -1/3, -4, -1/2, -3, -1. So let's graph these. -5, -1/3, -1/3, -4, -1/2, -3, -1. And then it said -2 error. What happens is the graph will never touch -2. So there's going to be kind of an imaginary vertical line that this graph never touches. And if we look at our table, on the other side of -2, -1, 1, 0, 1/2, 1, 1/3. So let's graph those. So -1, 1, 0, 1/2, 1, 1/3. So let's try to make, I'm going to get rid of this dot that I shouldn't have had there. Let's sketch this graph, and if you remember, it hugged the x-axis, and then it went through these points, and then it got close to this x equals 2 line, but it never actually touched the x equals 2 line. And what happens is if we put in -2, we end up dividing by 0, so it's undefined, so it'll never touch that. But if we put in like -2.01, you get 1 over 0.01, which ends up being, this is 1/100th, so 1 divided by 1/100th is 100. Sorry, negative. I had this wrong. It'd be -0.01. So at -2.01, you're way down at -100. So every time you put a number in that's close to -2, it's going to approach, really big negative value. If you're talking about something that's on the left of -2. If you're talking about something that's on the right of -2, like 1.999 or 1.99, -1.99, I'm sorry, we get 1 over positive 0.01, which is 100. So it's going to start way up above and come down, and then it's going to hug that x equals 2 line, and it's going to go through these points and hug the x-axis again. And the reason it hugs the x-axis is this will never, ever be 0. You will never be able to touch the x-axis. You'll never find a 0 of this polynomial, because 1 over something will always give you a number unless it's 1 over 0, and then it's undefined. So this fraction will never give you 0. Okay, let's talk about a vocab term here. We have 2 lines that this graph approaches, but it never touches. So these 2 lines, let's do a dotted line. are right here at x equals 2, and right here at x equals, or at y equals 0. Let's make these different color. We'll make that red. We'll make this one also red, just so they kind of stand out. Okay, so we have two lines. This is called a horizontal asymptote, and this is called a vertical asymptote. And an asymptote line, we can kind of type this out, and asymptote is a line that a graph approaches. Is that right? But never touches. And this is mostly true. Sometimes a graph will cross an asymptote line, but it's really talking about the end behavior, what's happening on the end of the graph. And we haven't talked about end behavior yet, but when we get there, this will make a little more sense. But an asymptote line is something where the graph approaches it, but it never touches that line, as you can see in this example. Okay, so this is infinite discontinuity, where it has a vertical asymptote line. In this example, it also has a horizontal asymptote line. Okay, next is point discontinuity, and this is when you divide by 0, so this is the other case where you divide by 0, but the numerator has the same factor as the denominator. So what am I talking about there? Let's take a look at this. And let's look at the graphing calculator first. I'm going to go to y equals, we're going to unhighlight that first one, and let's highlight this graph. So it's going to graph this x squared plus 5x plus 6 over x plus 3. And it looks like a nice straight line. Maybe we need to adjust our window or something, but it is a straight line, and there's a reason it's a straight line. But what's weird is that look at this equation. This does not look like a line. This is not y equals mx plus b. This is something weird. It's got, it looks like a parabola on the top, a line on the bottom. I don't know. It looks really weird. So what I'm going to do is I'm actually going to factor the top and see what I get when I factor the top. So this factors into x plus 2 times x plus 3, and the bottom is x plus 3. So what happens is we can really cancel out the top and the bottom, but in this equation we still are dividing by 0, so you can't just cancel it out and then ignore the fact that this x plus 3 ever existed. But this is going to look like the graph of x plus 2, y equals x plus 2, so that means I have a y-intercept of 2 and a slope of 1, so it's just going to keep going up at a rate of 1 and down at a rate of up 1 over 1 type deal. So it's going to look something like this. But, so I said it's discontinuous, but it doesn't look discontinuous. It's got a nice straight line. I could draw this, I could trace this without lifting up my pencil. If I look at the graph, I don't see any issues. There's no hole or anything like that. But there really is. The problem is, as you get close to -3, there is a hole at -3, because if we look at the equation, if you plug -3 in there, you're going to divide by 0, and it tells you on the table. So if we look at second table, at -3 you get an error message because you're dividing by 0. So if you're at -3.001, there's a value, and if you're at -2.999, there's also a value. So it looks continuous, but it's not. So the way we do that is we go to x equals -3, and we put an open circle at x equals -3 to kind of tell the person looking at the graph that this is continuous everywhere except at this point, and that's called a hole. So these are the three types of discontinuity. We have point discontinuity, where you cancel out something in top and bottom and there's a hole in the graph. We have infinite discontinuity, where there's a vertical asymptote. And we have jump discontinuity, where this graph on the left and the graph on the right have a vertical gap in between them. And that is the beginnings of continuity.